In this tab, we will evaluate the efficiency of distractors and explore ways to improve them. Please note that this section is only applicable for binary items such as MCQs. In MCQs, the incorrect answer options are called distractors. Distractor efficiency assesses how well these options serve their purpose of misleading students who do not know the correct answers. It is important to note that the calculation of distractor efficiency depends on the number of options available for each question. The first step is to select the number of options per item. For example, if most items in the test have 4 options, we select 4 as the number of options. When the distractor efficiency is 100%, it indicates that all distractors are effectively misleading students who did not know the correct answer. The closer the distractor efficiency is to 100%, the better the distractors perform. For demonstration, let us change the number of options per item to 3. You will notice that the distractor efficiency increases, with some values exceeding 100%. This result indicates that the test items have more options than claimed, leading to an incorrect distractor efficiency calculation. On the other hand, if we change the number of options per item to 5, the distractor efficiency decreases, which is also inaccurate because the calculation assumes an incorrect number of options. Next, we analyze the distractors for each item in detail. For example, in the first item, 1 is the correct answer, and 13 students selected it. The RSPP value displays the proportion of respondents who chose each option. In this case, 87% of students selected option 1, while no students selected option 2. Meanwhile, 7% of students chose options 3 and 4, respectively. However, an option 5 appears, which is incorrect because this question only has 4 options. This discrepancy occurs because some questions in the test have 5 options, and the ItemAnalysis-IMU assumes that all questions have the same number of options. Therefore, the 5th option for this item should be ignored. The PB is value, or point biserial correlation, measures the relationship between selecting a specific distractor and the total test score. A well-functioning distractor should show a negative correlation with total test scores because high-performing students are less likely to select incorrect options. If a distractor has a weak or positive correlation, it suggests potential issues, such as unclear or misleading wording. The next column shows the discrimination index of each distractor, calculated by subtracting the proportion of low-performing students who selected the distractor from the proportion of high-performing students who did. A well-functioning distractor should have a negative discrimination index. Finally, the table provides the number of students in the lower 27%, middle 73%, and upper 27% performance groups. These groups are categorized as low performers, average performers, and high performers, respectively. If you prefer to view these numbers as proportions instead, you can toggle the corresponding button. For example, in this case, the table shows that 75% of low performers, 86% of average performers, and 100% of high performers selected the correct answer. This detailed analysis helps to refine and improve the test items and their distractors.